Welcome to solving systems of equations by substitution method or equal values method. When we have two equations with two variables, we can find the solution to those equations. So let's go about it here. We have y equals and y equals. So we can set whatever y equals to each other. So if y equals 2x and y also equals 5x minus 15, that means we can set the 2x and the 5x minus 15 equal to each other. From here, we use our previously learned methods. We can subtract 5x, flip it over the other side, and complete the problem from there. Divide both sides by -3, leaving x equals 5. Do not forget to go back up and find your other half of your coordinate. You plug 5 in, y equals 2 times 5, so y must have been 10. So if these lines were graphed, they would cross at 5, 10. And it is always a good idea to go back, check that out. 5 times 5 is 25, minus 15 would give you 10. So it does solve both equations simultaneously. This equation requires a little bit more work. Equal values is not the best method here, so we're going to use substitution. Well, if y equals this, 5x plus 16, wherever we see y, we can replace it with 5x plus 16. So we can take this and plug it in for y. Do not forget parentheses, because in this case we want to substitute the whole quantity 5x plus 16 in, and that equals -1 still. And you solve from here. Do not forget your distribution property, 10x plus 32 equals -1. Solving from there, I can combine like terms. I get 11x. I will also flip the 32 over to get -33. Divide each side by 11. X equals -3. Substituting it back up, I can find that 5 times -3 is -15 plus the 16, so y must be 1. So my answer is x equals -3 while y equals 1. That solves both of these simultaneously, and it is a good idea to go back and check to make sure it does work in the other equation, which it does. The last one, as you notice here, a little bit trickier. You have to make a decision which variable to solve for. I want to make it look similar to this problem, where it's a variable equals an expression. Well, I can do that fairly simply by flipping the 4y over to the other side. And now I have x equals, so I can substitute this quantity for wherever I see x. So 3 times 4 minus 4y, and then copy down the rest of the problem. Similar to the other problems, now we just have to finish it off using the distribution property here, and you will get your answer. So that is solving systems of equations by the substitution method or the equal values